Good afternoon, everyone, and welcome to the first episode of our podcast. In this episode, we will focus on from waste heat to resilient energy solutions, how thermal storage, more precisely underground thermal energy storage and geothermal solutions can power our future. I will be the moderator for this podcast. My name is Abdulrahman Dahash. I'm a scientist at AIT Austrian Institute of Technology, where I'm leading the topic large thermal energy storage or underground thermal energy storage for district heating and district cooling applications. So we have heard many times that our energy transition is often described as a race toward renewable electricity, but there is another side of this story as well that receives unfortunately much less attention, which is about the thermal energy, heating and cooling in building stock, for example. So every day, if we look around, there is enormous amount of heat, thermal energy that is produced and produced by industries, for example, power plants, buildings, and even the data centers that power our AI tools. Much of this valuable energy simply disappears into the air or even into the subsurface if we have underground technologies. At the same time, we continue, if you look around, we continue to burn fossil fuels to produce heat or even thermal energy when we need it later. If you think about it, deeply, this raises an important question. What if we could save the heat instead of wasting it? Now, this is where underground thermal energy solutions together with geothermal systems become incredibly exciting. So if we store heat beneath our feet, we can simply bridge the gap in this seasonality between when renewable energy is available, for example, during summer, and then when the society really and actually needs it during winter, for example. So today, through our podcast, we will explore in this journey from waste heat to underground thermal energy storage up to geothermal integration. Then we come back to the electricity and power to heat technologies directly with the broader challenge opportunities for creating more a sustainable energy system here in Europe. That's why today I would like to welcome 5 experts in this field. They will bring their expertise from different perspectives of energy systems, geothermics, underground thermal energy storage, district heating, and cooling systems as well. So please welcome with me Professor Tobias Schrag. He is the head of the Institute of New Energy Systems at THI, Technische Hochschule Ingolstadt. In his research, he focuses on heat pumps, buildings, district heating and cooling, low exergy networks, and also dynamic simulations. He will be representative for the project INTERSTORES. Moving to another project that will be FlexGeo, we will have 2 colleagues. The first one would be Kai Zosseder. He is the chair, he is the head of Geothermal Energy Group at the chair of Hydrogeology at Technical University of Munich. And his research focus goes more towards the subsurface where we have the geothermics energy and also the underground thermal energy storage. He will be backed up via his colleague, Christopher Schifflechner. He is working at the chair of energy systems at Technical University of Munich, and he focuses as well on geothermics, waste heat, and dynamic simulations together with heat pumps. Then moving to a third project that will be REWICH. Our representative for REWICH will be Dr. Dongyu Meng. She has a PhD in chemical engineering at University of Birmingham, and she focuses on the development of thermochemical thermal energy storage solutions for future power generation. And finally, from the project GEOSYN, we will have Matteo Morival, and he will be our representative for GEOSYN. He is a project manager at the French company NeoEco. So welcome, everyone. Well, if we want to set the stage regarding the waste heat and to think about it, there is an important question that is rarely questioned or rarely raised. So we often hear that energy is being wasted here and there. You can hear it in media, for example. You can hear it also when you are getting in a bus or even in a tram. But the question that remains untackled to those that aren't expert in this field, where does this waste heat actually come from in everyday life, and why we are still letting this amount of heat or this waste heat, so to say, as a valuable resource go unused? For this question, I would like to hear the opinion from Tobias, if you don't mind.
Hello, everyone. So, in your everyday life, for example, you're using a fridge, and to cool your fruits or your nutrition, and on the backside of the fridge, heat is given away. At the same time, you use some fossil fuels to produce hot water you need for showering, even in summer. So ideally, you could make use of the heat produced at the backside of your fridge to shower. Though this doesn't work out in just a small systems, but if you enlarge your system and you think, okay, a data center needs some cooling, and this is a lot of heat that is produced, and the data center likes to get rid of this heat and is throwing it away, and that's called waste heat. But on the other side, maybe an industrial process needs some heat, or several heat pumps need some low temperature source to produce heat. Then this heat could be used. And in a larger system, then it makes sense to recover this waste heat that you can't really recover in your fridge. Your fridge is heating your room. Maybe it's nice in winter, and then you're already using it. That your kitchen is heated by the backside of your fridge. But in summer, you like to avoid it, and we need some technical systems to match these supply of waste heat and demand on some other sides.
Thank you, Tobias. Could you please also elaborate more about the dynamic pattern of this waste heat? Is it constant over the year? Is high rise, dumping, declining? And to which technologies you would always contribute? So I mean, like this waste heat, if it is from a data center, it is constant over the year. I believe the listeners would like to hear about that one as well.
Yeah, it depends very much on the sources. Some sources are rather constant, and some sources only emit in summer, and maybe some sources even only emit heat in winter. So there is a dependency of what is your heat source, but there's often a mismatch between place and time of the produced waste heat and the demand for this waste heat. And if if demand and supply do not match, then you can use a storage, and that is what we're doing and researching INTERSTORES is how we can store the produced waste heat in that is produced by a data center uh, into some time slots when there is need for this waste heat. And there's definitely this seasonal aspect that heat is produced in summer that might be used in summer, but there also might be shorter time periods where we can also use a storage for to transfer the heat into the time slot where heat is needed.
Perfect. Thank you. And I like the term that you have used, a resource. So you think waste heat is a resource that simply arrives at the wrong place or the wrong time, right?
Exactly. That is at the same time we use fossil fuels to just produce what we just throw away at the other time. So and like many of our waste is nowadays recycled, we should do the same with the energy that we are wasting, yeah, at the backside of our fridge or at the top of our data centers.
Okay, perfect. Perfect. So to the listeners, waste heat you can dispose of. It's something like an energy resource that you can simply take advantage of instead of wasting it. Thank you, Tobias, basically. So you have mentioned also, Tobias, InterStores project. And could you please introduce the technologies that you are using for capturing this heat within InterStores project?
Yeah, we basically in InterStores we have two very different technologies that is at the slightly unusual storages where we try to enlarge the capabilities to store heat. One is at a demo site in Germany, in Ingolstadt, where we have an so-called thermal source network where we have very low temperatures, and there we because if you store low temperature energy, then the volume needs to be bigger to store the same amount of energy. So we really have an economic pressure to be really cheap, and that's why we're trying to reuse already existing infrastructure. Also, this sort of resource reusing is we're using an old basin from a refinery that is now used as a thermal storage that is integrated into these thermal source networks that can provide cooling and heating at the same time. The second technology we are investigating in INTERSTORES is at the other side, it's on very high temperature, and that's in Finland. And here we are researching cavern storages for temperatures with 120 degrees that is needed for a thermal source network in the region around Helsinki and the two surrounding cities. So the most populated area of Finland.
Perfect. Thank you, Tobias. And now I would like to move to Kai, because what was said by Tobias raises a very important question regarding the subsurface. And I believe, Kai, you are a specialist in the subsurface, right?
Yes.
Perfect.
I hope so.
You are. So my question would be, why storing heat, or let's say thermal energy, in the underground or in the subsurface more generally, such a promising solution compared to another energy storage methods like the above ground tanks or even latent heat storage or other technologies? And the second part of this question that I see, and I have even went to this vision, that what makes the subsurface such an effective thermal battery?
Yeah, thank you for the question. So first of all, what we need, especially in thermal energy storage, we need a huge volume. So there's a huge amount of energy what we need. So where do we get this volume? And if you be on the surface, you have to build huge tanks and all that stuff. You need space for it, and especially where we need the heat in dense urban areas, for example, because that's the heat sink. So there we do not have a lot of space. So the space is one of those. And in the underground, you see that we have a lot of space available. And what we have in the underground as well is we have a pot where we have a water. And water, of course, the groundwater, it has a very good heat capacity. So it is a very, very good and very feasible to store the heat there. And we have a huge amount. That's a main advantage, I would say, for the underground storage systems. And of course, you don't need surface. You don't need the space in the surface. And you even don't say it where it is, but you can use it in a large volume.
Thank you, Kai. I would like to take advantage of your expertise, and it would be great if you can tell us about the different technologies for underground thermal energy storage from your perspective.
Yeah, there are at least two. What you have to distinguish, that is, of course, then so-called closed loop or open loop systems. So you can use borehole heat exchangers or probes, where you just put in, so you drill a hole and put in some pipes, and then in the pipes you can circulate a heat carrier media, and so you can actually, just inject heat, store it here, and then bring it back with these probes. On the other side, it is ATES systems, so aquifer thermal storage systems, which use the groundwater, as I said before, directly, which is already in the underground. So you can actually heat up the groundwater and then pump it back if you need.
Perfect, thank you. How about pit thermal energy storage, cavern or mine thermal energy storage? Do you see them as competing technologies to ATES and BTES?
No, I don't say it. It's of course pit storage. It's a little bit different, pit storage. I have to say, per definition, is it an underground? It is an underground thermal storage, but it's used use a tank in the underground, I have to say. So it's maybe a little bit different. Do not exchange quite a lot with the underground conditions. It's of course different from cavern and mining systems, which can be used quite a lot. I would say there's a high potential because we have a huge volume available somewhere, which we can fill in water and which we can use here for these storage systems. So, and I don't see any competition here. It is just what do you have available at which place? Because that counts at the end. So if you have a cavern available, if you have old mining place available, then of course you can use it and you can try to use it. There is of course always different challenges to use it. Yeah, so going to hydrochemistry or whatever. But you can solve it technically. I'm quite convinced. And then you can make use of it, what you have at the specific site.
Perfect. Thank you, Kai. But this raises an important question to me because my background during my PhD, I investigated tanks, so subsurface tanks or underground tanks, and also pits. And at that time, we found out that the interaction between those facilities and the groundwater might lead to worsen the efficiency. But what I understood from your speech or from what you have said is that for ATES and BTES, the groundwater flow would be wished in this case because it increases the capacity. Right?
I want not directly. So flow is difficult. So if you have a flow, of course, and you use it for the underground, then your heat flows away, maybe where you don't want to have it. So the efficiency, if you have a high ground, the flow really, the efficiency maybe decrease. So, but if you have a groundwater which is not flowing, which exists quite a lot of times, yeah, so it's a stable groundwater system, then you can use it quite very efficiently. So, of course, then the specific hydraulic and underground conditions must be taken into consideration by designing such a system. That's, of course, very important. But we make quite good experience with it. It works quite well.
Perfect. Thank you, Kai. So now we have discussed storing heat. There is still another technology or another topic that I see it kind of complementary to the underground thermal energy storage. It's still in the subsurface environment and it goes more to geothermal energy. And how do geothermal energy and underground thermal energy storage solutions complement each other in a real energy system rather than competing, as we said, competing technologies? Can they work together? And as I understood, this is also one of the scopes that you have within the project, FlexGeo.
Yes, of course, and it fits quite well. So what you have in geothermal energy, you have a lot of energy, heat energy available in the underground. And this is available 24/7. So you can actually produce out of the underground energy the whole year with the same amount. So what, of course, if you implement such a geothermal energy system for district heating grid, for example, you design the geothermal wells for wintertime normally, where you have a high demand of heat. So, but the whole geothermal system is available in summer as well, and you need just a small pot of the heat in the summer for hot water. So what those you have to reduce the production of the geothermal well. And coming to the investment, so you need a lot of investment for a geothermal energy system, and you want to have it as efficient as it can be. So it would be very good if this geothermal system run the whole year through. Yeah, then you have a lot more full load hours, and that's quite good for your efficiency. So you can produce out of heat out of these geothermal wells also in summer, but there it's not needed. So combine the geothermal system then with thermal underground storage, maybe in different horizon levels where you have colder temperature or something like that, makes totally sense. Then you can actually produce the heat out of the underground, run your geothermal system more efficiently with a lot of more full load hours, and then use the heat for the peak loads, which is not covered by the geothermal system. Normally, geothermal systems are designed more for base loads, so you can combine it and it can reduce the need of fossil fuels there, although for peak loads, and can combine it in a very efficient way.
Thank you. Thank you. I believe this is a very important outcome and insight as well for the listeners, because often we hear also from operators of district heating systems that geothermal energy is competing with underground thermal energy storage. But if you think about it, they are complementing each other. One goes more for the peak load, the other one either base load or helps in the intermediate. Thank you, Kai. I would like to move further to Christopher, who is the project coordinator also of FlexGeo. And I would like to hear from you, Christopher, more about the technologies or the span of the technologies that you are considering within FlexGeo and what would be the goal of FlexGeo as well, since you are dealing also with geothermal energy and underground thermal energy storage. The floor is yours.
Thank you very much, and also welcome from my side. Yeah, and I think like the two first speakers, Tobias and Kai, showed very perfectly the high potential of the underground thermal energy storage. With fluctuating heat sources, we have the possibility to store huge amount of heat on the subsurface, and then we can harvest it in whenever it's needed to decarbonize heating supply. So therefore, of course, it's about the temporal profiles of the heat source and heat demands for the storage system. But we see that, of course, the temperature levels of all of those involved parts is also crucial for practical implementation. And unfortunately, sometimes those temperature levels do not match, that you can combine the three steps, charging, storing, discharging in one system without having more advanced surface technologies like heat pumps in between. And this is what we want to do in FlexGeo, that we develop advanced flexible surface technologies which can help geothermal energy by making it more flexible, and also therefore integrate large-scale underground thermal energy storage in a more economic and a more efficient way into a future energy system.
Thank you, Christopher. Could you please tell us which type or technology of underground thermal energy storage?
So in the project, we are mainly looking into both aquifer and borehole thermal energy storage. So those are the two use cases we are investigating. So there, but then we cover a broad range of temperature levels. So with some partners, especially from Catalonia, we're looking into fifth generation networks and then using BTES systems for low and medium temperature storage. But together with Kai and his team, we are also then looking into high temperature ATES and BTES systems and how to charge and discharge them in the best way integrated into a district heating network.
I'm happy to hear that one, because for BTES, sometimes BTES or ATES, I believe that geological conditions will govern always whether you go for very high temperature or low temperature. I remember when I went through the webpage of FlexGeo, I saw that you are also focusing on organic Rankine cycle. Is that correct?
Exactly. So, but in combination with the heat pumps. So, because we see high temperature heat pumps as one of the most promising technological concepts to decarbonize the heating sector and to push the development of medium and deep geothermal energy further. But especially for heat pumps, which are applied for peak load coverage, that they might only run maybe between November and February, they have economic challenges. Ecologically, it's very attractive to use large-scale heat pumps for this peak load coverage because they can substitute then gas or oil peak boilers, which are currently often used by district heating operators. But to pay back the investment for the heat pump, it's tough when it's only operating 1,000 or 2,000 hours, and most of this time it's also operating in part load. So for us, the question was, how can you utilize the surface equipment more efficiently over the year to make a robust business case for the operator? And therefore, we are now developing and testing a novel heat pump technology, which can also operate as a power plant, as an organic Rankine cycle by using the same equipment. So you don't need to pay twice for one power plant and one heat pump, but you pay for one installation, which can then quickly switch between power plant and heat pump mode. And this is one of the main objectives of FlexGeo, to test this technology for the first time in the world on a large scale level together with our industry partner, Orkan Energy.
Oh, that's quite interesting actually to hear. And I believe the listeners will follow that one as well, because if I would like to summarize FlexGeo in one sentence or even in one term, I would call it CCHP, so combined cooling, heating, and power. Would that be correct in this case?
Yep. So it addresses very precisely what we are covering in FlexGeo. But of course, we look into different application scenarios, case study regions across Europe. So therefore, it's not always that we have done all the technologies for each of the case study regions, but in the ideal case, here with our advanced surface technologies and a better integration of high temperature underground thermal energy storage, we hope that we can develop more economic, more efficient geothermal systems, which can then provide heating, cooling, and power generation to the customers.
Okay, all the best. This is quite interesting. All the best from my side.
Thank you.
Perfect. So as we have heard up to now, that one of the biggest challenges of renewable energy is that the nature doesn't match always our energy demand. So for example, you might have the solar heat availability during summer, but the heating demand is during winter. So the sun shines when we may not need electricity or even thermal energy, and the wind blows on when it is, for example, it's windy outside, so on its own schedule. And this is where thermal energy storage can become a powerful bridge, as we have seen up to now from the two projects. So FlexGeo and INTERSTORES. There is a third project also is dealing with this aspect that is called ReWitch. So I would like to ask Dongyu, could you please introduce the project and elaborate about the concepts and the technologies that you are developing within that one?
Yeah, hi. In terms of the ReWitch project, the idea is we capture the solar energy and to storage it, and then integrate with the existing industrial process and to increase and improve the system efficiency. And also, we already develop develop thermal energy heating and cooling technology to balance the demand within the existing industrial process. So that's the ReWitch project's concept.
Perfect. And as I understood, you are developing also a thermochemical energy storage, right? Or
yes.
Could you please elaborate about that one? Which materials you are using? What is the concept? Because when I went through the webpage of the project as well, and I followed some of the literature about that one, what I found is that you are focusing more on power to heat technologies, but not in the conventional form. More, it is in a different form that you have wind, you have like, let's say, solar energy, you convert it via thermochemistry, for example, like chemical engineering principles into thermal energy heat by absorption, desorption, for example, or something similar. Could you please elaborate about the technology that you are dealing with?
Yeah, so actually the thermal energy storage concept is simple, is that we trying to capture the surplus heat or electricity, converted the electricity into heat and storage it, and then use it later. So the first concept for us from Birmingham is that we actually explore not only thermochemical storage technology, including latent heat storage and also sensible heat storage. So let me give one example is that from the wind energy side is that we have a UK-China collaborated project on 2016. This is the first commercial and large scale phase change material demonstration plant for curtail wind power plant. So the idea is that the wind farm can produce more electricity than the grid can use. And the clean electricity can be converted into heat. And the heat is then stored in the special material. So in this case, composite phase change material, it means latent heat storage technology is used in this project, and then release the heat later for space heating. So this can So the wind power plants not only producing renewable electricity and also turning the surplus renewable electricity into useful and low carbon heat. So for the other technology like REVEACH, we are trying to using the thermochemical storage material to capture the solar energy or the waste heat from the industry. So the basically is a chemical reaction. So chemical reaction when it occurred for example the desorption process, it needs heat from outside. So if the temperature can reach like a 120 or 90 above, so the material can be destroyed. For example, the water in the material can be released and blow up and dry the material. And then it's concept as heat already stored in the material, in the thermochemical materials. And then if we would like to use the heat, we can blow the moist air into the reactor or to contact with the material. And then the chemical reaction happen again. And then a large amount of heat can be released. And then we can use this heat for the heating application. So that's the concept of thermochemical heat storage.
Thank you. Thank you for this elaboration. I do have one question that is also perhaps will be shared by many listeners. What is the storage material in this case that you are using?
That really depends because some of them, it's like a formulation from different research institute. So basically, right now is can be used like the sorption base. It's like silica gel, and also zeolite. This is some kind of sorption material which can be used, and also active carbon. And the second part is the salt hydrate. For example, like the magnesium sulfite, and also screaming borate, and some kind of the salt hydrate can be used. And also the moth, which is the metal frame. It can be absorbed like gas and then exist the heat and release the heat. So there is several type of material can be used in the thermochemical heat storage concept.
I do have one short, picky question in this case. Do you see these technologies, the thermochemical ones, competing with the underground thermal energy storage for district heating applications?
So this is every type of thermal energy storage technology have their advantage, pros and cons. So from the underground thermal energy storage, because it's local and large and already available underground, so it's very abundant. You can use it directly. So, however, the disadvantage is it stores sensible heat. It means, for example, the groundwater, you heat it up to 100 degrees C. If you did not use it or not very insulate very well, the heat will gone and the water will be cooled down. So, and also the heat can store in the water is limited. So, however, for the advantage compared to thermochemical, so there we can claim very minor heat loss during very long-term storage, seasonal storage. For example, the heat is storage, you dry the material, the heat is already storage in the material. So if it is in a closed chamber, and you store it for a long term. If you want it and you blow the reaction gas into a reaction, so and it can release again. And also the thermochemical material, the energy density, they can absorb like 3 or 4 times higher energy, more than the water or sand or rocks. So that's the potential in the future, because it has very higher energy density and very minor heat loss during long-term storage. So, but now the disadvantage of thermochemical is that the system is a little bit complex than the ground thermal storage. So it's now already under very fast development. For example, the REVEACH project. already include collaborate with 27 institute and company and industries together to solve this problem. And from UOB side, we already have at least four projects like this to help with upgrade the industry process of the company already existing.
Perfect. Thank you, Dongyu. So up to now, we have heard about two promising examples for thermal energy storage. They are quite promising candidates for our sustainable energy system or future energy system. And technically speaking, many of these solutions already exist, yet we don't see them everywhere, or we don't see any acceleration in the uptake for those technologies. So my question goes more to Matteo in this case. So what is holding us back from accelerating the uptake of these technologies? If these technologies are so promising, as we have heard up to now, what are the biggest barriers preventing their uptake or accelerating their uptake today? Is it political? Is it economical? Is it the investment, regulation, public acceptance, citizen engagement, and so on? So Matteo, could you please elaborate more on this one?
Yeah, sure.
So despite of their great potential, the geothermal storage energy and energy are not yet widely deployed. There is remaining challenge. The first one is policy and regulation. So permitting, it's a kind of long-term planning. There is some standards. Also, there is some infrastructure issue by district heating networks, existing building, or grid integration of new building in the heating system. Then we have the public awareness and acceptances. So for people, it's depending on the pan-European culture, it's difficult to understand the technology and to have confidence in this new solution. The technology level, it's also there is different level of technology, but the in pumps, the storage materials, the drilling system, and also the integration in the building are mature or weak depending on the different European region. And then we have also the economic viability. So we have high upfront investment in terms of capex. It's increased the cost of the building to be constructed, and then the business model. It's mainly based on electricity costs that we know that are not very stable in terms of finance. So through our GEOSYN project, we mainly focus on the public awareness to build confidence in geothermal energy through community involvement in different European regions, and also have some educational initiative, policy guidance to develop recommendation for policymakers to support the integration of geothermal energy into different strategies, so very local at the scale of the city, regional or national energy strategy. And there our third level, it's the industrial impact, so to take different case study and recalculate the business model for them by transforming an energy intensive, so something that use fossil fuel, such as food production or cement manufacturing, to a natural heat solution that reduce both operating cost and carbon emission, and to see what are the benefits of this transition with a case study.
Thank you, Matteo. Since you have brought already the project GEOSYN, I believe one of the things that you have mentioned, it is the regulation and the political aspect as well, right? As barriers. So
yeah.
Exactly. And what I wanted to know, so within GEOSYN project, do you consider, for example, different European countries, and you compare also between those countries the regulation or the regulatory frameworks when it comes to geothermics?
Yeah, exactly. GEOSYN is based on an European cooperation. So we combine the expertise of Italian, Danish, Norwegian, French, and Ukrainian partners to solve this complex energy challenge for the different context. So we see that in many countries there is no a clear framework for large-scale underground thermal storage or geothermal heating system. And also there is a gap between the different procedure for permitting in some country. It can be very complex and so time consuming, and so slow down project.
And could you tell us about one interesting difference between those countries when it comes to the subsurface or geothermal, something that you have noticed through the running years of the project?
Yeah, so basically based on how the technology is implemented in country where they are well implemented, so Germany or Italy, the policy is more, it's more easy to implement new project, and for some projects who are very complex seismic procedure for drilling, etc., it's very strong to transform the infrastructure. And I can take the example in France, for example, where this development could be lower. And in GEOSYN, we also focused on the Ukrainian reconstruction virtual scenarios. So how to transform industry in Ukraine to promote a faster, greener, and more affordable reconstruction here. And in Ukraine, it's really wide. Yeah, there is no clear rules. So it's also why our project push for policymaker to make a technology transfer from Europe state of art to Ukraine and help them to implement their own legislation.
Perfect. Thank you, Mathieu. Thank you a lot for this elaboration. So to our listeners, many of today's challenges, as we have heard, aren't purely technical, as they require engineers, scientists as well, who understand our energy system and also our environment from surface to subsurface to air as well. And they can also communicate across different disciplines and can translate this research or research activities more into practical solutions. This brings me to the final question. And luckily, four of our guests, experts today, are involved into academia and educating also the next generation of engineers. So I would like to finish with something that is kind of a forward-looking question or with a vision. So my question goes to Tobias, to Kai, to Christopher, and also to Dongyu and Mathieu. Please, also you are involved in this one. The question goes like this. So do you think that the current engineering and also science curricula are properly prepared and properly also preparing our students in the bachelor and also in the master level to tackle these real world challenges of integrated energy systems together with the environment, with the air, with the power generation, with the cooling, with the heating, and also different perspectives from underground thermal energy storage, where we have civil engineering, mechanical engineering, subsurface, where we have also hydrogeology and so on. So do you think that the current curricula in our universities can prepare the students to face those or to encounter those those challenges? I would like to start hearing from Tobias, please.
Actually, I think yes. This is in most of the study programs I know that are teaching renewable energies. Storage is a vital element, and there definitely not all facets of storages and underground facilities can be covered in study programs, but at least these thinking in an energy system where you need a storage to balance supply and demand, because you have these fluctuating resources, is inherent in many of our study programs. So I think that is there is a new generation of engineers coming up that is really trying to harvest a lot of coming back to the waste heat, that is trying to harvest a lot of the this wasted heat in storages, but definitely there is a limit what you can prepare students for in STEM, especially if you go into geology. I mean, I I come to my limits very soon. That and I'm constantly learning on that one. So you can't really prepare students for the for these all these challenges. If you go into that direction, then you need to keep on learning all the time.
Thank you, Tobias. Which brings me to our next expert, that is Kai. So, what do you think, Kai, on that one? Do we need interdisciplinary?
I would agree and disagree. Is because I think, the idea about storages and the need of it and how to handle all the dynamics is there, and it's teached. But I think again, what you said, the interdisciplinary challenge, what we have. This, I think, is not totally covered, because if I look at the universities, even the chairs who are doing this stuff are not optimal connected in some ways, I would say. So there could be a lot more interdisciplinary approaches, and what we need also in lecture. So energy world gets more and more dynamic and more challenging and more putting all different parts together, because we have not one central station what actually delivers us the energy whenever we want. No, we need, especially in renewables, a more dynamic world, and I would say it needs also a more dynamic teaching for that one, more interdisciplinary, cross-cutting issues, what we have to integrate here in some parts would help. I see in some parts it's on the way, but not as much as we needed, I would say so.
Thank you, Kai. I would also support you on that one, but let's also listen to Christopher. What does he think about that one?
Yes, thank you. Yeah, I think about the better connection between different disciplinaries, both Tobias and Kai said already quite a lot, and I agree there. What I also see from our daily life is the challenge or the potential in connecting students also by the teaching closer to the research activities we are carrying out, because we see often in the standard lectures it's either then teaching good fundamentals to understand physical processes, or then showing already applied technologies like conventional market ready ones. But often now we see there's this gap also with respect to then energy planners, operators, or so on, that they really understand how close to market some innovative technologies already are, because often for them they just start looking into technologies once there's a first commercial demonstrator. And we saw, for example, by engaging students with master theses, lab courses with our technologies, by doing experiments and so on, they go to the industry after the masters. And then at some point, the company reaches out. Yeah, we heard now by our young employee that this technology is already way more advanced than we thought. So it might be possible to make the first demo project. So I think really teaching students the mindset that technology is always developing further. And at universities, we're also doing sometimes, I think, more applied research closer to market than industry things. If this stays stuck with the students also once they go to industry, I think it will in the future more easier to transfer and translate our research activities into real market application.
Thank you, Christopher. Dongyu, what is the situation, or how would be the situation at University of Birmingham?
I would say that really depends on the platform. Because luckily our platform learning and teaching is very good, because based on my experience, because I do my PhD here and I supervise some of the master students also. So their project and their thesis is basically oriented from our research project. Our research project, including for example, the UK EPSRC project and also the industrial project. So they have the opportunity to directly get in touch with the industrial. So some of them can learn a lot from the process, what's the needs of the commercial market, and also what they should learn from the university theoretically. So this is a very good opportunity for the student in our group, but facing to a broader range of students is that they are their resources are very limited. Basically, if they just taking the lessons from the classes, and that's very limited to them. Basically, they can know more. They can know more about is about the lecture they can explore. So that really limited. That's the case in Birmingham.
Okay, thank you, Dongyu. Then the last one would be Matteo in this case, and I would like to hear your opinion from a different perspective since you are more into the industry. So when you welcome a new colleague who is freshly graduated from the university, do you see they are capable to do the job directly, or they need some mentoring or long-term mentoring, short-term mentoring? Could you please elaborate on that one?
Yeah, as you explained, and thanks for it, I will mainly represent the SME and mid-sized company. So for this kind of very mixed field application between thermodynamic, building engineering, and also process industries, it's very hard, and it will depend on how is made the management of the company and how is the politic of innovation implemented. But basically, it's very important to have a new skill and this kind of new energy development expertise. So I will really support all kind of students that coming from this field to manage this transition.
Perfect. Thank you, Matteo. And I would like to ask each speaker for one last word. So, Tobias, your last word to the listeners, what do you advise them?
I would say be open to these new development of storages that are coming up. I think that is a spectrum to be enlarged, and where we see an uptake of the market. So there will be new opportunities to take part.
That's a very good one. Stay open to the new technologies. Thank you, Tobias. Kai, how about you?
I would go in the same direction. I would say, yeah, keep your eyes open of new possibilities, especially in the underground, because there are a lot of innovations are left to whatever. How can we use gravel beds, whatever you find out, and then think about it. How can we use it, and how can we use the synergies which are already there?
Thank you, Kai. Couldn't agree more. Just stay your eyes open for the subsurface. Christopher, how about you?
Yeah, in general, not much to add again. But yeah, really don't fixate too much on just reference projects, which may already have a good solution, but not have the best flexible solution for your individual case. So therefore, really explore innovative solutions. Maybe dare something with good development partners, because in the end, you can really benefit economically, ecologically quite a lot if you really have a well-designed system for your case and not just copy-paste something from a different case framework.
Thank you, Christopher. Dongyu?
I totally agree with that. The experts' idea is be open to the innovative technology. But I would like to add in one more sentence is that scientific and innovative technology go to the market is a long journey. So we should do the useful things during the research. It's the market-oriented research. So that might be useful for scientific or researchers.
Also agree on that one. Thank you, Dongyu. And finally, Matteo.
Yeah, no, I don't have any opinion on this question. Sorry.
Okay. Would you like to say something for the listeners as a final word, just to open their eyes about something, like stay open for new technologies, think about the business model, think about the regulatory frameworks that kind of protect you from any damage in the future. That's why trust those authorities and trust the new technologies, for example.
Yeah, when we think about geothermal energy, we usually associate with it in building, but in reality, geothermal energy can also support industrial process by providing sustainable heating and also helps city to achieve the neutral CO2 emissions. So it's more a global comprehension of our urban development and our ecology, industrial territory development. Yeah, in a nutshell.
Thank you. So thank you all for sharing your insights and experiences. This brings us to the closing of our episode today. Today's discussion and episode, it reminds us that achieving a sustainable energy future is about much more than generating renewable electricity from solar energy or from PV panels or even wind turbines. It's about using energy wisely, storing it when nature provides it for free, and then integrate it together with technologies that will allow us in the future to make the most use or the highest use of every single unit of energy and makes it almost free and decarbonized. With that, I would like to close the session or the episode for today and to thank all of our speakers for joining us, taking the time also to share their insights, experiences. Also, thank you to everyone listening. We hope this conversation has offered you a fresh perspective on the hidden potential beneath your feet about thermal energy storage, more precisely the underground one, and also geothermal energy, as they can play a definite role in our tomorrow energy system. Until next time, thank you for listening and stay tuned for the next episode.